All right, so in our first couple examples here, we're going to use the limit definition of the derivative, and we're going to try to unravel and see what derivative we have here. So if we look at this first example here, and what I like to do is I like to look at the second part here, and we can see the x squared. So my f of x has to be equal to x squared. So that means my f prime of x would have to be 2x because this is the definition of the derivative. All right, so what you're trying to do is you're trying to work backwards from the limit definition. You're trying to find out, you're trying to do the derivative in an easy way. So we look at the next one, and we can see our function that we have is tan x. So that means f of x is equal to tan x, which means that f prime x is equal to secant squared x. All right, in our next example, we want to recognize that we have the double minus sign here, and we have to remember that we are subtracting f of x. So that means this would have been minus some f of x right here. Well, if we have a two negative signs, that means that we must have had minus 2x squared plus 3x, and when we distributed, we got our minus sign. So that means in this case here, the function being disguised is 2x squared plus 3x. So that means that f prime of x would be 4x plus 3. Okay? And in the next example, we can have chains mixed in here. So f of x would be equal to sine 2x. Well, this, we can have a chain rule problem. So the answer to this would be 2 cosine 2x, because we have to multiply by the derivative of the inside. Okay? Okay, in these next two examples, what starts adding some confusion for students is when we replace the x by a value. So in this case here, in this first one, we have 3 plus h, the quantity squared, minus 9. Well, if we're doing this here, the 9 is the same thing as 3 squared. So this is the same thing as 3 squared. So that means that our function is actually x squared, but we're plugging in 3. So what we're finding is if f of x is equal to x squared, in this case here, we're finding out what is f prime of 3 equal to. And in this case here, the derivative of x squared is 2x. And if we plug in, so the derivative of x squared is 2x. And then if we plug in 3 into that, we're going to get an answer of 6. So this is one that can lead to some confusion with students. So they have to recognize that this is our x, and this here is still, the function that's happening. So we can recognize that we're squaring that. All right, so in the next example, another one that sometimes confuses students. Again, we're not using an x value, we're using the value 1. We're not using the letter x, we're using 1. And if we can recognize that this is the same thing as natural log of 1 plus h minus the natural log of 1 all divided by h, well, the natural log of 1 is 0, so that's why they don't have it written in the original. So this problem here is f of x is equal to natural log x, and what we are finding is f prime of 1, which in this case here would come out to be the derivative of natural log x is 1 over x, so the answer here is 1. All right, so we can also disguise the alternative form of the derivative. So this is the alternative form of the derivative. And we know that the alternative form, this is equivalent to f prime of a. So this should yield a value and not a function because we're plugging in an a value. So what we want to recognize is we want to recognize what f of x is. We want to recognize what a is. So this would be, f of x would be x squared. And we're finding f prime of the a value, 5. So f prime of x is 2x in this case here, and then we plug in 5, so that answer would be 10. All right, we can also discuss alternative form of the derivative, disguise a cosine. So f of x is equal to cosine x, and we want f prime, and the a value is pi over 4. And the derivative of the cosine is negative sine x. So this would be negative sine pi over 4, which would be negative root 2 over 2. Okay, I hope that helps. If you liked the video, please like and also think about subscribing. I have a lot of AP Calculus material. So again, thanks for watching. Have a great day.